Welcome back. In this video, I just want to take a few minutes and attack the idea of mass and also explain mass in terms of inertia. In our everyday common language, maybe somebody would describe the size of the sun as massive, or we use words like looks like you've lost weight. And maybe in our minds mass and weight are the exact same thing, but to a physicist they are very different. And there are definitely people out there that get volume confused with mass and volume confused with weight also. So let's just read these first two statements and see if we can clarify some things. The first statement says, the more mass an object has, the greater its inertia. And the more inertia an object has, the more force would be needed to change its state of motion. So if an object is really massive, a large force would be needed to either get it going or stop it from moving. So let's think of a school bus. We can think of a school bus as massive, and maybe we can think of a mouse as not massive. If a school bus is parked, that school bus is considered to have a large inertia compared to a mouse that is sitting still. And so it would take a lot of force to get the school bus going versus less force to get the mouse going. Or we can think of this in reverse. If the school bus is moving along and your job is to stop it, and the mouse is moving along at the same velocity as the school bus still has more inertia, and so it would take a greater force to stop it from moving, and it would take less force to stop the mouse from moving. Let's use this picture to explain the difference between volume, mass, and weight. These are called density cubes. What they are is they are cubes of all the same size, but they're made of different materials. And so in terms of volume, all of these cubes have the same size. So let's just define volume. Oops, go down here. Volume would be defined as the amount of space an object occupies. So if you look at these density cubes, they indeed are all the same size. They all have the same volume. Do they all have the same mass? The answer would be no. So let's define mass. Mass would be the amount of atoms Whoa, I'm kind of all over the place here, sorry. In an object. Some of the cubes are metal, some of the cubes are wood, some of the cubes are plastic, so they all have a different number of atoms that are in them. For example, the mass of the metal cubes is greater than the mass of the wood cubes, and perhaps the mass of the plastic cubes is also greater than the mass of the wood cubes. And that means that the metal cubes have more atoms in their volume than the plastic cubes, and the plastic cubes have more atoms in their volume than the wood cube. Okay, so that's the difference between volume and mass. Now what is weight then? Weight on Earth can be thought of as a vector. So weight. Weight is always acting downward. Weight is a measure of the pull of the Earth on an object. So weight is actually a force. The more mass an object has, the greater the force pulling down on it would be, and therefore the greater the weight the object would be. So when you stand on a scale, your mass gets on the scale, and the scale measures how much the Earth is pulling down on you with a force. And so typically your weight should be measured in newtons, but that is not the case because we live in the United States. So is it correct to say to somebody, wow, you must have lost weight? No, weight is how much Earth is pulling down on you. It's not really visible. It's more correct to say you look less massive. It seems like you've lost some mass recently. It's maybe not the most polite thing to say, but physically it's the most correct thing to say. So let me take one of these, let me give some units to these terms. If we take a 1 kilogram block, so we'll pretend one of these cubes weighs 1 kilogram. 1 kilogram, if you think back to science and the units that are in science, a standard unit, well, the kilogram is the standard unit of mass. So when you see kilograms, that is your mass. And typically in America, you hop on a scale, and the scale reads in pounds, so you are actually not reading your mass. But when you're in a science classroom and you put an object on a scale, the scale will read in grams or milligrams. You are reading the object's mass. You are reading the amount of atoms that are in that object. Well, if you take a 1 kilogram object on the surface of the Earth will pull down with a force, and that force is equal to, it's a nice number, 10 newtons. And so realize 10 newtons, this would be the object's weight. So a mass of 1 kilogram has a weight of 10 newtons, and I think this is where we lose a few people. In America, for every kilogram of mass that you have, your scale will weigh you, or will weigh 2.2 pounds. And so pounds is also a weight. Pounds is a measure of force, how much the Earth is pulling down on your mass. And so there is a ratio that is set up between all these numbers right now, and I'm going to write them up right up over here. 1 kilogram is equivalent to 10 newtons, and vice versa. 10 newtons is equivalent to 1 kilogram. 1 kilogram is also equivalent to 2.2 pounds, and vice versa. And then we also have another ratio that is set up such that 10 newtons is equivalent to 2.2 pounds. It's good to know these ratios. We can use them when we cross multiply and when we try to convert units in this section, and we'll practice this math a little bit this week. But as a quick review, mass is a measure of inertia. The more massive an object has, the greater the force it would take to get it going or to stop it. And that is a measure of inertia. And volume is the amount of space an object takes up. Mass is how many atoms are in the object. And then weight is how much force the Earth is pulling on the mass of that object. I hope this helps.